experiment is to find how the wheel ratio affects the distance and speed of the Mousetrap car by making changes to the original design.
And to find out how potential energy is transferred into kinetic energy. Variables. The independent variable is the wheel-to-axle ratio. And then the dependent variable is the distance and speed of the car that we measured during the tests. All right,
the controls are the lever arm,
the
whole front area, like the mousetrap, the zip ties, the size of the paint sticks,
also
and the front axle,
and then the front
wheels. The front wheels.
And then the thing we changed was
the Menards lids as wheels, and then the size of the drive axle, and it's smaller, so that's what makes it go farther.
Alright, investigative question. Does the wheel-to-axle ratio affect the distance and speed of the car? Distance hypothesis. If the wheel-to-axle ratio affects the distance a car travels, then it will travel farther than the control because we're making the ratio bigger. So the turning of the wheel is more efficient because as the wheel turns, the fishing line needs less line to turn the wheel, so then the wheel turns more efficiently.
And so it goes farther.
Yeah, and the axle also decreases, which makes it easier for the wheel to turn. So it needs a smaller rotation to turn the wheel as far as it goes.
Speed hypothesis. If the wheel-to-axle ratio affects the speed of the car, then the car will travel faster, because the ratio is getting increased, so the turning of the wheel is more efficient. So it goes faster.
Yeah, explained in our last hypothesis.
Yeah. Materials. 2 9.5-inch wheels, 2 large CDs, a fishing line like everybody else, 1 to 12 dowel rod, I'm gonna guess.
1 12-inch dowel rod.
Yeah, 1 12-inch dowel rod. 1 standard mousetrap, sadly not a rat trap. 2 5/16-inch washers.
Around the inside of the wheel.
Yep. 1/4 dowel rod.
This is your own handwriting,
2 16th dowel rod. What? That makes
it's a 3/16-inch
dowel rod.
Okay. And 2 paint sticks.
Oh, and 2 paint sticks, and
we should probably
and zip ties. And
a hot glue gun.
Here we go.
Control mousetrap data. Distance. Trial 1, 6.65 meters. Trial 2, 6.72 meters. Trial 3, 5.89 meters. Calculated average for distance, 6.42 meters. Speed. 0.56 meters per second. 0.59 meters per second. 0.55 meters per second. Calculated average for the control car speed trials is 0.56 meters per second. Data for our mousetrap car. Distance, 16.25 meters. Trial 2, 16.18 meters. Trial 3, 16.14 meters. Calculated average for our car in distance trials is 16.31 meters. Speed trials. Trial 1, 0.52 meters per second. Trial 2, 0.55 meters per second. Trial 3, 0.52 meters per second. Calculated average for speed test on our car is 0.53 meters per second. Data analysis for distance trials. Our car averaged about 16 meters over each distance trial, while the control car only averaged about 6 meters, 5 to 6 meters. This is over a 100% increase in our distance compared to the control car. I think it was because of the effect of the wheel to axle ratio, as it was more efficient in turning. Data analysis for speed trials. The control car went about 0.57 meters per second, while our car only went 0.53 meters per second. The wheel to axle ratio didn't really affect the speed as much because it meant to make the wheel turning more efficient and cause it to go farther. So all in all, it really didn't make a difference. The end. Distance car conclusion. If the wheel to axle ratio affects the distance a car travels, then it will travel farther than the control, because we're making the ratio bigger, so the turning of the wheel is more efficient. Our hypothesis was proven correct, because after the trials, our car had an average of 16.31 meters, while the control had an average of 6.42 meters. This was over a 100% increase. And just looking at one individual trial, and both our lower trials, so the control's lowest trial was 5.89 meters, while our lowest trial was 16.14 meters. There's still a huge gap in between those two. Now, after this, a couple ways to improve is there's more trials. More trials would add a little more accuracy and a little more diversity in the data. Accurate data down to millimeters. So that means when measuring, instead of doing just centimeters and meters, we do millimeters, and that'll give us a lot more accuracy, and it'll make the data a little easier to handle. All in all, the wheel-to-axle ratio affects the Mousetrap car in a positive way by making it more efficient, and it travels way farther. Speed trial conclusions. Alright, our hypothesis was if the wheel-to-axle ratio affects the speed of the car, then the car will travel faster, because the ratio is getting increased, so the turning of the wheel is more efficient. After doing the trials, our car actually went slower than the control car, as we averaged about 0.53 meters per second, while the control car averaged 0.56 meters per second. Although this is inconclusive because it's only a 0.03 meters per second difference, so you can't really draw a conclusion from that. So they're about the same. You can't really do much better or worse. Like over here, like we've had trials that went over other trials on theirs, and so you can't really draw the conclusion that one car's faster than the other. Now, when doing our wheel-to-axle ratio idea, we can't really, it wasn't more for speed, because what it's trying to do is making the wheels turn slower but more efficient. So what actually happened is the fact that we were able to make the car go farther instead of faster, which is an idea we traded off, but we just thought when we were creating the hypothesis that there was a chance of it going faster. Alright, more ways to improve is obviously, again, more trials, and also accurate data down to millimeters to give us more conclusive results, and stopping the stopwatch right on point something seconds. So instead of just rounding it up to 19 or down to 18, we make it up more. So all in all, the wheel-to-axle ratio didn't really affect the speed as much, but it affected the distance. So in relation to the control car, the data really was inconclusive, and we can't really draw if one was better than the other.